This question was asked by MIT Integration Qualifier exam in the year 2010, and this is question number 20. This I will use King's principle. Okay, so before that I will convert this sec is 1 by cos. Okay, therefore this is same as integral 0 to pi by 2. So sec is same as 1 by cos, so I am taking LCM. So cos will go off over here, cos x upon here, I will get sin x into cos x plus 1 into dx. Okay, now let's consider this is I. Okay, so I is this, and then let's substitute u equals to 0 plus pi by 2 minus x, or you can say pi by 2 minus x. Then my du is minus dx, and then when x tends to 0, then u tends to pi by 2, and then when x tends to pi by 2, then u tends to 0. Okay, so therefore this integral become 0 to, so 0 to pi by 2 become pi by 2 is 0 here, pi by 2 to 0. Cos x here, instead of x, what we can do is from here, instead of x, x equals to pi by 2 minus u. Okay, so this same as pi by 2 minus u upon, therefore here sine of pi by 2 minus u, and then cos of pi by 2 minus u plus 1, and my dx is minus du. So here minus du. This minus I can change by changing limit. Okay, so this minus I will remove by changing from 0 to pi by 2. Okay, we know that here, we know that sine of pi by 2 minus theta is same as here, pi by 2 minus theta is in here 0, pi by 2. It is in first quadrant. This first quadrant, pi by 2 minus theta is first quadrant. Here in this first quadrant, all are positive, whether it is sine or cos. So positive will come, sine will go to cos of theta. Therefore this is equals to 0 to pi by 2. Cos of pi by 2 minus u becomes sine of u upon cos of u into sine of u plus 1 into du. Okay, let's add these two. Okay, now this is my I, and let's add this one and this one. Okay, with the variable x. Okay, so therefore, so on the left hand side I will have twice I is equals to, that means from 0 to pi by 2. Okay, so I will have sin x plus cos x, sin x plus cos x, here sin x plus cos x upon here sine of x cos of x plus 1 into dx. Okay, now look at in denominator. Okay, so denominator, what do we have? Let's see. Okay, remember we have sine of x in minus cos of x the whole square is what? Is same as 1 sine square x minus twice sin x into cos x plus cos square x, means a minus b the whole square. Okay, so we need this. Okay, we need this term, means we need this term. Okay, so therefore it implies sine of x minus cos of x the whole square. Okay, and then here sin x plus cos x is 1. Okay, so is equals to 1 minus 2 sin x into cos x. So I will bring this side here, 2 into sin x into cos x equals to 1. I will bring this side minus sin x minus cos x the whole square. Okay, so these two I will send this side. Okay, instead of this I can write like this. Okay, so now if I add plus 1 on both sides. Okay, so this is, this we have. Okay, now if I add 1 plus sine of x into cos of x is what? 1 plus 1 minus sin x minus cos x the whole square upon 2. Okay. So this sum as, if I take LCM, then 2 plus 1 minus sin x minus cos x the whole square. 2 plus 1 is 3. Okay. 3 minus. So instead of this, I can write like this. Okay. So therefore, instead of this, I can write 3 minus sin x minus cos x the whole square sin of x plus cos x into dx 0 to pi by 2. Okay, here all we have on the left hand side twice I. If I substitute this as a u, then I will be getting differentiation over here. Okay, therefore this way. Okay, so instead of 3, I can write square root of 3 is same as 3 is same as square root of 3 the whole square. Now if I substitute this as u equals to sin of x minus cos x, then my du is differentiation of sin is what? Cos x minus minus plus sin of x into dx. Okay, therefore whole this. Okay, so whole this is my du. Okay, and then let's change the limit. When x tends to 0, sin 0 is 0, then cos 0 is 1. Okay, so I'll get minus 1. When x tends to pi by 2, then u tends to 1. Okay, so twice I is equals to limit become 0 means here minus 1 to 1. This become my du upon square root of 3 the whole square minus u square, and we have integral 1 upon a square minus x square dx is equals to 1 by twice a log of a plus x upon a minus x. Okay, so let's apply this. So if I apply this equals to 1 upon twice a here 2 into root 3, and log of a is root 3 plus x is u upon root 3 plus u, and then limit is from minus 1 to 1. Remember, we have on the left hand side, so these two I will send to the 4. Okay, so I will send for I equals to this. Okay, 1 by root 3 log of 2 plus root 3. Okay, check whether this is come or not. So just you have to substitute limit, you will get this answer. Thank you.